Hey everybody, this is Miss Peachy from your WCA Physics class, and I am doing a little video to kind of explain a bit what to do for your upcoming physics portfolio. So in your physics course tree, here I am in the course tree, you'll see that this is Unit 1, Lesson 7, Graphing Motion. So you have two options for this portfolio. The portfolio option that's actually given to you in the lesson, if I click on that, and you open it up, you click on this link, it's going to actually open up this document here that I have up on the screen for you. Now, this is a hands-on activity. And for this hands-on activity, you are going to create position versus time graphs and velocity versus time graphs for an actual toy car that you have moving. You can have a wind-up toy car, or you can have a battery-operated toy car. And you're going to set these up, and you need to have a stopwatch and be able to measure its position in a certain period of time, and then graph these and answer the questions. So it's pretty straightforward and pretty simple. Problem being is that many of you I know are going to be in a situation where you don't have these materials at home. You don't have maybe the toys, you don't necessarily have a stopwatch, although with our phones we pretty much have stopwatches all the time. So I'm going to actually give you an alternative activity to do. You can still do this one, okay? So you can still do this one, and if you do that, you would save this to your computer, the student lab report, and upload it to the Dropbox. That is completely okay. You'll also then need to make some graphs of this, and then you would save those graphs separately and upload those graphs as a separate documents, or separate probably Excels or spreadsheets or whatever that you would put on in the Dropbox as well. So you might have multiple things to upload into the Dropbox. So this is completely acceptable, but I'm giving you an alternative today for those of you who don't have the materials. So you're going to find the alternative stuff on my website. Remember that you can get to my website through the push pin icon at the top of your screen. That will take you to the section message boards. And when you get to the section message boards, you just follow the links for the physics message board, and it will take you to a link to my website, which will look like this with the B on it. At the top of the screen, there's a link for physics, which is what you're going to click on. And as you have been kind of building this up in the last couple of weeks here, as you scroll down, let's see, where is that little guy? Here, it's under labs. Oops, hang on a second. Okay, so I'm sorry, I must not have saved my update on my Google site, but it's under labs here. And you will see right here where there's a little gray box is the video that I'm recording right now. So I'm going to put the link to that video here. But the other box is going to give you a worksheet that you can do. So I'm going to open up that worksheet. It's actually a Google Doc. You can download this to Word if you want to, which is probably the easiest thing to do. Or you can print it. Actually, to be honest with you guys, the easiest thing you can do for this is to print it and then do a pencil paper, and then scan it back into your computer and upload the scanned document to me. That would be great. If you can't or don't have a printer, you can just have this up on your screen and write your answers on a piece of paper. You have to draw pictures of graphs, so it'd be easier to write them on a piece of paper and then use your phone to take pictures of that and then send me the pictures. Ugh. That's an alternative. It's not my favorite way. I'd rather that I get the scanned documents, but if that's the only way you got to do it, guys, that's the only way you got to do it. So your two options for this are to print out this worksheet and do it, and then scan it to your computer and then upload that scanned document to me, a PDF to me, or write all the answers down on a piece of paper and then take a picture of it and then upload those picture files, those JPEG picture files to me, okay? Which again isn't the best way to do it, but sometimes it's the only way we got. So what you're going to do is you're actually going to use a website called PHET, P-H-E-T. So there's a link to PHET, And it's going to open up this activity called the moving man right here. Okay, so we're going to click on the moving man activity, and that will open it up. And when you do the moving man activity, you're basically going to be predicting what the graph of the man's motion is going to look like. And then you're going to then allow the man to complete the motion, and then you're going to see what the graph actually looks like and compare the two. Okay, guys, this is literally about 3 minutes later. It's taking quite a while for this to load for me. So I just wanted you to be aware of the fact that it sat there and spun for a long time before it loaded this screen. So I'm not sure if this is the case every time you'll get on PhET. PhET generally ran a lot of sims that used Java and sometimes Flash and stuff like that. So I think they're really kind of trying to make it so that you can still use it even though Flash isn't going to be supported after this year. So that's my guess, is it was trying to kind of make it run on your computer where normally it wasn't running very well. So if it takes a few minutes for it to run, don't freak out. It took, like I said, at least 3 minutes or so for this to load for me. And as you can see, I'm at home, so I'm just using my home connection. So once you have it loaded here, now you can see kind of the functions of what you need to do. So if we look at this one, so what we need for our first situation is a man moving from the center of the screen 0 meters to the house 8 meters at a slow and steady pace. So these are your predictions, and you're going to draw your predictions like in one color pencil, and then you're going to draw the actual graph in a separate colored pencil. So you should have 2 different graphs. 2 different lines on each graph, I should say. So there's going to be 4 total lines. Now, as I said before, if you can't print this and you can't draw on the printed copy, then you can do this on a pencil paper. And then you would just put down for this one, you are on number 2. So I would number this number 2. And then this was 2A. And I would put my position versus time graph. I'm just going to copy this picture. Just copy all this information so that you can replicate that graph, right? So I put lines for 5 and 10 and -5 and -10, and then my time in seconds. So I'm essentially just going to draw just like it's on the screen there. So just like this, I'm replicating this little empty graph. And then right next to it, I'll draw this one too. And then I'm going to make a prediction of what I think the graph is going to look like. I might draw like a line on the graph, and that's my prediction, right? And once you have your prediction for both position versus time graph and your velocity versus time graph, then you're going to actually have the man do that action and see what it looks like on the graph. And using a different color, you'll put a different colored line. Just make sure to give me like a key. So if you're using your black pen as your prediction and your red pen as your actual, make sure you label those so I have a key for that graph. Okay, once I do that, you go to the PhET app, wherever that guy is here. And it said, remember, he's moving from position of 0 meters to positive 8 meters. Okay, and the way you do that is you're going to start him at 0, and then you're going to change the velocity to a slower velocity. Say we do, I don't know, 2 meters per second. And then we're going to hit play until he reaches that 8 meter per second mark, and then we'll hit pause. So he's moving at a slow and steady rate. He's pretty slow. Maybe I could have sped them up a little bit, huh? But it said slow and steady. Jiminy Christmas. Okay, I'm just going to put when he's like crossed the 8 meter per second mark. Then we look at the chart, and the chart is going to actually show you. Okay, take that back. You actually need to hit chart first. Get my thing over here, and then plug your numbers in here. Okay, so if I can reset this again. So if he starts at 0, then I want to put my velocity in here, and I'm going to put it at 3 just to make it go a little quicker. At a slow and steady pace, so this should be, slow and steady. He's not accelerating at all. He's staying at, constant acceleration. So we are going to hit play and watch him walk again to that 8 meter mark. And then this is how the graph's viewable. Apparently you can't just look at the other screen. You have to click on charts. I was incorrect on that one. I better move my face out of the way. Still kind of going real slow. Patience on this particular portfolio, ladies and gentlemen. All right, so once he hits that 8 meter per second mark, come on, you can do it. Almost there, buddy. All right, and we can stop it, and you can kind of see what the graphs look like for position versus time and for velocity versus time, right? So then you can write these on your piece of paper. You can either draw them in a different line, right, on the same graph, remember, as you drew your first one. I think I did pretty darn good with my position versus time prediction, right? We would just draw it with a different color on the same graph right there. Or if you have the worksheet printed out, which is preferable, you do it right on there, but on the same graph. Okay, so you're going to do position versus time and then velocity versus time. Okay, and just those two. Okay, so you're going to do that for other scenarios. A man moving from 0 to the house at a faster pace. Man standing still at 4 meters. The man moving from 0 to the house at a fast pace and then moving back to 0 at a slower pace. The man moving from 8 meters to the tree at a fast pace. The man moving from 0 to the house speeding up as he walks, right? So again, you're going to look at your prediction and compare it to what actually happens. Then you have another scenario here, okay? So you're going to look at scenario G. The man stands still while he talks on a cell phone at the middle of the sidewalk and then walks towards the house at a constant rate, trying to get better cell reception. He comes to a sudden stop when the coverage is good about a meter before the house, then stands still to finish the conversation. Okay. Along with all of these predictions, by the way, once you have the graph and you write your line for what you think is going to happen and the colored line for what actually happens, I want you to give a verbal explanation of why you think it looks that way. So you are explaining in words what's happening on the graph. Oops. So back in this one, you could explain in words what's happening on this graph. And he is walking towards the house, so the line is a positive slope. And it is linear because he is moving at a constant velocity. Okay, so that's what kind of explanations you're going to give on these. Finally, when you are done with all of your graphs and predictions, you have one more to do, and we have a graph on here, and you're going to come up with a scenario to explain this graph. So you think about those scenarios of the man walking, come up with your own scenario to explain what is happening on that graph, okay? All right, ladies and gents, I hope that makes sense. Again, that's an alternative to the one that uses the toy car and having to set up like a little course for your toy car and use a stopwatch using this online sim. If you have any questions, please let me know and I'd be happy to help you out. Have a great day.